Aij of m by n, of order m by n. It has m rows and n columns. Then the transpose, nothing but the transpose of a matrix capital A can be denoted by a to the power of t. A to the power of t. A power t is equal to a j I. I j becomes j I. Ij becomes j. Nothing but the row becomes column, column becomes row. The row becomes column and column. Nothing but I will represent, I is represent row, row becomes here j. J becomes I. And also order becomes change. Okay, so what is the order? N by n becomes n by n. N by n becomes n by n. Nothing but if A is 2 by 3, let us consider A is a given matrix of order 2 by 3. Then what is A transpose matrix? 3 by 2. 3 by 2, right? See here, parallelly, clearly I said that parallelly I will start that OBT questions also. OBT, don't be absent even C-section students. Right? Fine. So, for example, I am taking here the matrix A is 1, 2, 3, 4. Then what is the transpose of a matrix becomes? See, I said that is nothing but you have to interchange. You have to interchange. So write rows as columns and columns as rows. Okay, right? So row, what is the first row? 1, 2. You can write as first column. And what is the second row? 3, 4. You can write as 3, 4 as second column. That's it. So it is a clearly square matrix. And also remember that in the transpose of a matrix, the given matrix no need, it is must be a square matrix. So not necessary that it is square matrix. It may be any kind of matrix. So, okay, right. Now, if I take any other 3 by 3, I am going to take a 3 by 3 matrix I'm taking simple example 1, 2, 3, and 2, 5, 6, and some 3, 6, some minus 10 I am taking. Okay, so clearly I am taking here a 3 by 3 matrix. A 3 by 3 matrix. Then can anyone tell what is the transpose of a matrix here? Transpose. So the first row is 1, 2, 3. 1, 2, 3 you can write as first column. Row become column. And what is the second row? 2, 5, 6. 2, 5, 6. The third row is 3, 6 minus 10. 3, 6 minus 10. Is it clear? So like that. So this is the transpose of given matrix A. Just interchange. And moreover, if we observe here, so what about A transpose? A transpose, is it equal to given matrix A or not? Both will be
Yes.
equal or not? Yes, anyone? Is it both matrices are equal? A and A transpose? Yes?
Yes, sir.
Am I audible clearly?
Yes, sir. It is equal.
So here A transpose clearly equal to A, nothing but it satisfies this condition. Very important condition. Okay. So the matrix capital A. So let us take A be the given matrix. Capital A be the given matrix. The matrix capital A is said to be a symmetric matrix. A power T is equal to A. In the same way, the matrix capital A is said to be a skew symmetric. A power T is equal to minus A. So this is one of the example of symmetry. So after interchanging rows and column, we got A power T is equal to A. Okay, right? So A power A is called symmetric. In the same way, if you see the properties of a symmetric and also the properties of first transpose of a matrix. Okay, so I think you got idea about transpose. The transpose in the sense interchange rows as a column, column as a row. So, and here the transpose of a matrix having some properties. What are the properties of transpose of a matrix. First property and important property is that A transpose all transpose is equal to again the matrix. Okay, so look at here, this is the matrix. This is the matrix A, and this is the A transpose. Again, you can find A transpose, whole transpose here. Again, interchange here. Again, we are going to get the same matrix. Nothing but A transpose, whole transpose is clearly equal to A. Yeah. Second property is A plus B, whole transpose can be written as A transpose plus B transpose. Okay, like that. And also, third property is very important property. When I take multiplication, AB over transpose clearly equal to B transpose A transpose. Okay, so before discussing the properties of symmetry and skew symmetry, first we should know about the transpose of a matrix. Okay, so if we can write fourth property also. When you take the K is a constant. K is a constant. So A whole power T can be written as K into A power T. K is a constant. We can take completely outside. So this is the fourth property, right? Okay, now, so coming to the properties of symmetry. Properties of symmetry. So first you have to remember that the symmetry. What is the mean by symmetry means? So A power T is equal to A. Like that, what are the matrices are symmetric? Okay, like that. So what are the matrices are symmetric means? Simply observe here. So minus A. First one is minus A. A is a symmetric, minus A also is symmetric. Okay, right? And coming to the second one, uh, A power T. A power T already we proved. Okay, so clearly here A power T whole power T is equal to A power T, that is equal to A. Okay, we can write A power T whole power T is equal to A power T. A power T is equal to A. Okay, nothing but A power T also is symmetry. When I transpose the A power T, again we get A power T. Okay, right? A power T is symmetric. And A inverse, that inverse concept we will discuss later. So A inverse also symmetric. A plus A power T also symmetric. This is completely OBT concept. And NCERT students also try remember, very important, right? So A plus A power T also symmetric, and A power N. Okay, for example, A is symmetric. If you square that A square will get. A square also symmetric. Cube, A cube. Multiply A into A cube. That is also symmetric. Like that, A power N also symmetric. After that, A into A power T. A is symmetric, A power T is symmetric, their product also symmetric. Okay, and A power T into A. So, right, this is for only A. This is for only unique matrix A. If I take two matrices, like I am taking A power T is equal to A, B power T is equal to B. Okay, nothing but what do you observe here? A is a symmetric, B also is symmetric. Is there any properties which is belongs to A and B? Yes. The properties is A plus B also symmetric, A minus B also symmetric, AB plus B also symmetric. Okay, not AB. I'm not saying that AB is a symmetric. AB, the product may or may not be symmetric sometimes. Okay, right. So AB plus BA must be symmetric. Addition. AB plus BA. The sum of the product of two matrices must be a symmetric, but I am not saying that AB is a symmetric. So when AB is becomes symmetric, so A is equal to B. A is equal to B. Okay, that under limit. So simply up to here you have to remember the properties. Okay, right? So what are the properties when A and B are the symmetric matrices? A plus B is symmetric, A minus B is symmetric, and AB plus B also symmetric. Okay. So symmetric means after interchanging the rows and columns, again we get the same matrix, that is symmetric. So coming to the skew symmetric. Skew symmetric, let us see the example for skew symmetric. For example, I am taking here I'm taking here A is equal to like 0, 2, minus 3, then minus 2, 0, 4. So here 3, minus 4, 0. Okay, so section 6 student already knows this property, right? Yet, what do you observe here in skew symmetry? What do you observe here symmetry? What do you observe here skew symmetry? So symmetry, if you observe the symmetry, diagonal, whatever it is, diagonal whatever it is, because the diagonal element cannot be changed. Here 1 5 10, here also 1 5 10. Diagonal in symmetric matrix should not be changed. Not only symmetric, even in transpose of a matrix also, diagonal elements cannot be changed. Only other than diagonal, that is non-diagonal only will be changed. But to write the symmetric matrix example very easy. That is when you take other than diagonal elements. When you take 2 here, here also you can take 2. When you take 3 here, here also 3. When you take 6 here, here also must be 6. If you take here a different values, we don't get a symmetric matrix. Okay, so symmetric example is diagonal whatever it is. It may be zeros, it may be non-zeros, it may be imaginary values also. Imaginary values also. But only the condition is that the corresponding elements are same. So how to write mathematically? We can easily write mathematically also. The thing is that the matrix capital A is equal to Aij of M by M. Okay. And also remember that the transpose of a matrix, to find the transpose of a matrix, A may not be square matrix, but coming to symmetric and skew symmetric, the given matrix must be a square matrix. The given matrix must be square matrix. Look at here, two more example I am going to give you. Like A is equal to like 1, 2, 3. What is A transpose? Here column matrix, column becomes rows. I said very clear. That is the transpose of a matrix. Easier, yeah. A power T is equal to A. Easier, A power T is equal to A. No, because it is not a square. So due to that reason, so whenever we want to discuss about symmetry and skew symmetry, given matrix must be a square. If it is not square, symmetric skew symmetry does not exist. And also, but transpose exists for all kind of orders, right? Okay, fine. So the matrix capital A is said to be a symmetric. Yet Aij is must be equal to Aji. Okay, Aij for every I comma j. Simple. Nothing but what Aij. For example, this is A12 element. This is clearly A21 element. A12 first row, second column. Second row, first column. So Aij is equal to Aji. 2 equal to 2. Now what about this 3? A13 first row, third column. 1 3. First row, third column. And what about this 3? Third row, first column. What do you observe here? I becomes J, J becomes I, right? 1, 1, 3, 3, 1. I, J, J, I. Okay? This is the mathematical representation of a symmetric matrix. Aij is equal to Aji for every I comma J. Okay, remember, right? In the same way, what about the skew symmetric? Skew symmetric matrix, I am going to give example. Like I am taking here, like just now I already have written. So 0, 0, 0, 1, 2, 3, minus 1, minus 2, minus 3. So what do you observe here? In skew symmetric matrix, the diagonal elements always 0. Always must be 0. If you take any one of the values non-zero, it is not a skew symmetric. Okay, skew symmetric in the sense diagonal elements are must be 0 always. And another, that is first point. The coming to the second point is that so Aij must be equal to minus Aji. Here plus Aji. So coming to here Aij is equal to minus Aji. So the sign will be changed. Here plus, here minus, here plus, here minus, here plus, here minus. In case here minus, here it should be plus. If you take minus 2, the corresponding the odd diagonal element has to be like opposite sign. Minus 2 becomes plus 2. Plus 3 becomes minus 3. But diagonal element has to be 0. So this is the example of a skew symmetric matrix, right? Look at it. Whether it is skew symmetric matrix or not. Let us check now. So all of you find that A to the power of T, A transpose. What is A transpose? So the first row becomes first column, like 0, 1, minus 2. Next to second row, minus 1, 0, 3, minus 1, 0, 3. And the third row, 2, minus 3, 0, 2, minus 3, 0. Clear? 2, minus 3, 0. Now, is it equal to given matrix? No, it is not equal to given matrix because here plus 1, here minus 1, the corresponding elements are not same. Okay, so but when I take minus common here, then 0 is 0, minus 1 becomes the diagonal elements are 0 only. Minus 1 becomes plus 1, minus 2. When I take minus common, minus 1, minus 2 becomes plus 2, and minus 3 becomes plus 3 becomes minus 3. Because I am taking minus common outside. Okay, so now if you observe here, A transpose clearly equal to minus A. So this is clearly the given matrix. This is clearly the given matrix, nothing but after interchanging rows and columns, finally we got minus A. So A to the power of T is equal to minus A. Clearly this matrix is clearly a skew symmetric matrix. Skew symmetric matrix. And just two important properties are there for skew symmetric matrix, right? So let us discuss the two important properties for skew symmetric. The first property is that A minus A power T. When A is skew symmetric matrix, so A minus A power T also a skew symmetric matrix. And second one is AB minus BA. AB minus BA also a AB minus BA also a skew symmetric matrix. So you have to take any two skew symmetric matrices. Once you have to check it. Okay, so you can check whether AB minus BA is skew symmetry or not. Okay, right? So, like we can take n number of example. Just first you have to take the diagonal elements of 0. I have taken 3 by 3. Your wish. You can take 4 by 4, 5 by 5, 2 by 2, the matrix, right? So, when you take 4 by 4 also, first you have to write first all diagonal elements are 0. Remaining elements are same but opposite sign. Plus 1, same you can take 1 only, but minus 1. Minus 2, plus 2. 3, minus 3. That's it. So this is the concept which is related to symmetric and skew symmetric and transpose. So transpose of a matrix of order need not be a square, but symmetric skew symmetric must be a square, and remember the properties also. Sometimes in MCQs and case study, they may ask in board also important, right? So these are the symmetric matrices. So these are the skew symmetric matrices properties, right? Fine. Let us discuss first. I hope that everyone having that MJ uh, material, right? See, if you see the few questions in exercise 2 classwork, so first few questions which are related to matrix and multiplication. Okay, after that, the question which are related to symmetry and skew symmetry. First, let us do uh, the question which are belongs to uh, algebra of matrices. Okay, right? Yeah, if you get any doubts, you can ask, right? Right. The first question for classwork 2, okay, for NCERT students also you have to do this. Okay, these questions are which are related to multiplication. Right. See here, first one for the matrix capital A, for the matrix capital A value they given like 3, 2, 1, 1, right? 3, 2, 1, 1. The value of A comma B, the value of A comma B, the value of A and B such that clearly I am writing the question. So B1, B2 students also try to do this such that it satisfies the condition A square plus A into capital A plus B into capital R is equal to 0. Okay. All of you try this question. First option they given like 2 comma 3. Second option they given as like 1 comma 4. And third option they given as like minus 4 comma 1. And the fourth option they given as minus 2 3. Minus 2 3. Okay. So what is the mean by that? Generally, in OBT question, you should not waste the time. Okay, so you can do like shortcut methods. Okay, so you should find the solution in shortcut, right? Within 2 3 steps, you have to solve it, right? Let's see how to find the A comma B value. So first, what is their A scale? A scale. Okay, so A square nothing but A into A. Even first I'm going to tell you the shortcut method. So 3 to uh, 1 1 3 to
Sir, you're not audible. Sir,
Sir, unable to hear you, sir.
can you hear me now?
yes, sir,
Is
now.
it clear now?
Okay.
Yes.
Okay. See, first I'm going to explain the shortcut method, how to find the A comma B, how to check A comma B. See, already they given 4 options A comma B value. Trial and error method, how to verify the A comma B value. So, so finding total all 4 values, the time wasting process. So just to find the first value. So A square, the first element is 11. A square, the first element is 11 plus A into small a into capital A. Nothing but what? So when capital A they given as 3211. So when you multiply with a small a, we are going to get like that. Okay? Multiply with a scalar. So A into 3.
So you are not audible, sir.
It's going to be battery is down. So you can try to find the value. I'll come. Okay, just a moment. Yes, students, actually battery dead. Students, this is the only problem.